Ladies and gentlemen, today we are going to review some topics for the unit test. In this lesson, we are going to go over all these contents: absolute value functions, piecewise defined functions, transformations of piecewise defined functions, rational exponents and properties of exponents, adding and subtracting polynomials, multiplying polynomials, multiplying special cases, factoring polynomials, factor ax squared plus bx plus c, factoring special cases, quadratic functions in vertex form, and quadratic functions in standard form. Let's get started. The first question, it says that write the radical using rational exponents. Remember that, ladies and gentlemen, to be able to write this expression, this radical expression, as a rational exponent, you can write it down as a x to the power negative 6. The degree of the radical, which is 5, is going to be written in the denominator of the exponent, which means that negative 6 over 5 is the expression which is written rational exponent. Next one. Solve the given equation. This is one of the exponent equation. To be able to solve this kind of expression, the most important thing is you try to make the bases equal to each other. When you look at the left side of the equation, this is one of the exponent, 4 to the power x over 4 times 4 to the power x over 3. Remember that if you multiply two exponents with the same basis, we are going to add powers. So now we can add them up: 4 to the power x over 4 plus x over 3, which is equal to 4 to the power 7. Remember that, ladies and gentlemen, if you have an equation, exponent equation, if your bases are equal, then you should expect the exponent to equal to each other as well. So what does that mean? X over 4 plus x over 3 will be equal to 7. To be able to add these two fractions, you have to find the common denominator. So common denominator is 12. How am I going to make the first fraction's denominator 12? You need to expand by 3. So it's going to be 3x over 12. To be able to make the second fraction's denominator 12, you need to expand second fraction by 4. Then you will get 4x over 12, which is equal to 7. Because of the denominators are equal, you can add them up. 7x over 12 will be equal to 7. If you use the cross multiplication, the denominator of the 7 is 1. Use the cross multiplication. 7x times 1 is equal to 7x, which will be equal to 7 times 12 will be 7 times 2 is 14. 7 times 1 is 1 plus 1 is going to be 84. Divide both sides by 7 and x will be equal to 12. Same type of the question. The first expression on the left side is 4 to the power x over 5 plus 1. On second expression is 4 to the power negative 19x over 5. Remember that if you have a two exponent which is equal to each other, means if the bases are equal, then you should expect the powers to be equal to each other as well. So x over 5 plus 1 will be equal to negative 19x over 5. Before using cross multiplication, what is the denominator of the 1? Is 1. To be able to add them up, you should make the denominator equal to each other. We know that common denominator is 5, so that's why you can rewrite the expression with the common denominator. X over 5 plus 5 over 5 will be equal to negative 19x over 5. If you add them up, you will get x plus 5 over 5 will be equal to negative 19x over 5. So you can cancel out denominators because denominators are equal to each other. So what do you expect? X plus 5 is equal to negative 19x. If you subtract x from both sides, you will get that 5 is equal to negative 20x. Divide both sides by negative 20, and x will be equal to negative 1 over 4. Negative 1 over 4 is the answer. Next question. In this question, ladies and gentlemen, look at this. So 16 to the power 1 over 7 over 4 to the power x over 7. If you try to solve exponent equation, the most important thing is you should make the bases equal to each other. Look at the numerator. What is the base of this exponent? Is 16. And look at the denominator. What is the base of this exponent? Is 4. So I try to make the bases equal to each other. How can I write the 16 as an exponent with the base 4? 4 to the power 2 is equal to 16, right? So I can write the 16 as a 4 to the power 2 to the power 1 over 7 over 4 to the power x over 7, which is equal to 1. Am I done? Not yet. Let's continue. If you take the power of power, how can I combine this? You should multiply. Let me multiply. 4 to the power 2 over 7, because 2 times 1/7 is equal to 2 over 7 over 4 to the power x over 7 is equal to 1. Now, our bases are equal. If bases are equal, if we divide two exponents with the same base, how can I combine it? You should subtract powers. So let's do it. 4 to the power 2 over 7 minus x over 7 is going to be equal to 1. I have a question. What numbers to the power what is going to be equal to 1? What numbers to the power is going to be equal to 1? If you get 0 power of any number, you are going to get the answer 1. So you are going to expect this power is equal to 0. So 2 over 7 minus x over 7 is equal to 0. If you add x over 7 to the both sides, then you can get that 2 over 7 is equal to x over 7. You can use cross multiplication, or you can cancel out this denominator and you can find that x is equal to 2. If x is equal to 2, then this equation is going to be equal to 1. Next question. This question is about absolute value expression. Before finding the answers, I would like to review the general form of the absolute value expression. Remember that, ladies and gentlemen, y is equal to a times, in absolute value, x minus h plus k is going to be your general form of absolute value expression. And h and k is going to stand for vertex. When you read the question, it says that give two examples of the function that include an absolute value expression and have a vertex of -1 and 3. When you look at here, your h value is -1, your k value is 3. Let me rewrite the expression. So y is equal to, or f of x, you can say f of x as well, a times, in absolute value, x minus, what is the h? Negative 1, plus, what is the k? Plus 3. From here, you can get that a times x plus 1 plus 3. So when you look at all these multiple choices, let's eliminate your choices. When you look at the a, you will find that, look at the inside of the absolute value, x minus 1. Unfortunately, this is not your answer. When you look at the c, you will get that the inside of the absolute value is negative 1. That's why this is not also true. But e could be answer. All right. Look at the g. G is not possible because there's going to be vertical transformation up 3 units. When you look at the b, unfortunately it's not, because k is not positive 3. When you look at the d, look at the inside is negative 1. This is not answer as well. F, this is also true. And h is not true. So your correct answer is F and E, because the question is asking you find 2 examples, and these are the 2 examples which are correct. Next one. Begin by graphing the absolute value function. F of x is absolute value x. Then use the transformation of this graph to graph the given function h of x is equal to, in absolute value, x minus 1 minus 4. In this question, we are going to graph first f of x and then h of x. So let me try to graph my coordinate plane. Remember that in our previous lesson, I mentioned that the best method is making a table. X values and f of x values, g of, not g of x, h of x value. You can give any x value to the function. I would like to start from negative 3, negative 3, negative 2, negative 1, 0, 1, 2, and 3. If we substitute negative 3 into the f function, you will get positive 3, because we know that absolute value of any number is positive. If we substitute negative 2 into the f function, you will get positive 2. If we substitute negative 1, you will get positive 1. If we substitute 0, absolute value of 0 is 0. If we substitute 1, you will get 1, 2, and 3. These are your ordered pairs. Let me graph f of x first. Negative 1, negative 2, negative 3. Positive 1, 2, and 3. And then you will get positive 1, positive 2, 3, 4, and 5. And also negative 1, negative 2, negative 3, negative 4, and negative 5. So your first coordinate is 3, negative 3, and positive 3. This is positive 3 and negative 3. This is your first point. Second one is negative 2 and positive 2. And next one is negative 1 and positive 1. Next is 0 and 0, positive 1, positive 1, positive 2, positive 2, positive 3, and positive 3. If you connect those points, you will get that this is your f of x function. I did graph my f of x. Now h of x. Remember that what was the general form of the absolute value function? Y is equal to a times x minus h plus k. H stands for horizontal shift, left or right, horizontal shift, and horizontal shift. And k stands for vertical shift, up or down. Look at this, ladies and gentlemen. if you look at the h of x function, h value is positive 1, because remember that the sign between them is supposed to be negative. So that's the reason h is positive 1. H is positive 1. What is the k? Negative 4. Can you please tell me what's going to happen? What is the transformation? Transformation is 1 unit right, 4 unit down, which means that each point of the original function in f of x is going to be 1 unit right horizontally, 4 units down. Let's start from vertex. This point is going to be move 1 unit right and 4 units down. 1, 2, 3, 4. So then your new vertex, which belongs to h of x, will be negative 1 and negative 4. As I told you, each point is going to move 1 unit right, 4 units down. So this point is going to be 1 unit right, is going to be here, 4 units down, 1, 2, 3, 4. Then this is going to be your new point. This point is going to move 1 unit right, it's going to be here, 4 units down, 1, 2, 3, 4. Then it's going to be negative 1 and negative 2. This point is going to be 1 unit right, 4 units down, 1, 2, 3, 4. Then it's going to be negative 2 and negative 1. After that, you can also continue with this point. This point is going to move 1 unit right, 4 units down, 1, 2, 3, 4. It's going to be here. This point is going to move 1 unit right, and then 4 units down, 1, 2, 3, 4. Then it's going to be here. After that, we are going to move this coordinate 1 unit right. It's going to be here. This is going to 4 and 4 units down. 1, 2, 3, 4 here. If you connect them, you are going to get h of x function. So this is h of x function after the transformation of f of x. So what is the transformation? 1 unit right horizontally, 4 units down vertically. And this is your answer.